Here's Chapter 8, which is about our moon and Mercury. There's actually several similarities between our moon and Mercury. Both don't have atmospheres. Mercury, of course, is a little bigger, but both are heavily cratered objects. In this picture, of course, we see our, one of the astronauts, one of the 12 people that walked on the surface of the moon back in the, starting in the 1960s and then in the 70s. One thing that's important about this, and let me just say right now, okay, I've taught astronomy for a very, very long time, and occasionally I'll have a student in class that says, "Oh, I saw something on the internet that said we never went to the moon, and can you prove that we went to the moon?" And it turns out, yes, you can absolutely prove that we went to the moon. All right. So one way, besides the fact that we can actually now we have technology in orbit, the space telescope and so forth, that can actually see the 6 sites on the surface of the moon. That's beside the point, right? So we can see the material there. But the other thing is that the astronauts, when they were there, placed little mirrors on the surface of the moon. Okay, so these mirrors have been used over and over and over since the 1960s and the 70s. And what we do is we bounce laser light off these mirrors. Now, if you just shot a laser onto the surface of the moon, just some random location, the moon would just simply absorb that energy. It wouldn't reflect it back whatsoever. But of course, we put the mirrors there, and we know exactly where they are. All right, so for me anyway, that's a pretty conclusive, very conclusive evidence that we went to the moon. All right, so and of course we did. It wasn't some Hollywood fake or anything like that. We went to the moon. All right. Anyhow, let's move on. So this is some of the things that we're going to talk about: the properties, the orbital properties of Mercury and the moon, their physical properties, surface features of the moon and of Mercury. Of course, I already mentioned one of those major features is the craters, the rotational rate. The moon actually spins exactly around its own axis in the same amount of time that it takes to go all the way around the Earth, which is roughly 29 days. All right, so and I've already talked a little bit about how we've sent humans to the moon. We've sent spacecraft to the moon. We've put spacecraft in orbit around the moon to study the moon, and yes. All right, so this is just more. Okay, so we'll talk about the surface of Mercury. What we believe the interior of Mercury is like, from scientific measurements. There's actually was a spacecraft. There's been a couple of spacecrafts, but the most recent one is called Messenger. The Messenger spacecraft that visited Mercury. It didn't land on Mercury, but it orbited Mercury for quite a while and gave us a lot of information. So we'll talk about the interiors of both the moon and Mercury, and also the origin of the moon. Where did the moon come from? Is it just a captured satellite and eventually became our moon, or is it something else? Did it form at the same time as the Earth did? All right, so so let's get into this. So as I said before, the distance to the Earth, between the Earth and the Moon, has been measured extremely accurately using lasers, and of course, using bouncing the laser light off the mirrors. All right. Of course, from looking at Mercury, of course, is the closest planet to the sun, and so you never really see Mercury very far from the sun. In other words, when you can see Mercury at nighttime, it's very, very close to the horizon. So it's either, right after the sun is set or just before the sun has risen. And, it looks, just like a star. But of course it moves with respect to the background of stars. All right. Mercury, just like Venus, undergoes phases. Of course, they're very hard to see. You need a telescope to be able to see that, but because Mercury is between us, between us and the Sun, it undergoes phases. The changing angles between the Earth, the Moon, and Mercury, just like this. The phases of the Moon, right, are caused by the changing angles, angles, I guess, between the Earth, the Moon, and the Sun. All right, so that's really what causes the phases of the Moon, and of course causes the phases of Mercury. All right, so here are some physical properties. Notice, it's the Moon isn't really that much smaller than the planet Mercury. Here's its mass, of course. 7.3 times 10 to the 22nd. Mercury is a little bit more massive, 3.3 times 10 to the 23rd. As I said, the size is a little bit bigger. It's always good to compare especially the inner planets to the Earth. And so, there's the Earth, of course, is the biggest of what's called the terrestrial worlds, the first 4 planets. And then you get to the gas giants, and they're much, much bigger than the Earth. But we'll always compare, the size of the Earth and the mass of the Earth to the other planets. The density of the Earth is, I don't really like these units right here. Normally we use grams per cubic meter, and so the Earth is about 5.5 grams per cubic meter. The Moon is 3.3, and Mercury, of course, is a terrestrial world, and so the density of Mercury and the density of the Earth are very close to each other, as is the same for Venus, and similarly for Mars. One thing I should point out right here: this is a rather low density for the Moon, and there's actually a reason for that has to do with the formation of the Moon. Mercury and the Earth have a pretty good size iron and nickel interior, and the Moon does have some iron in its interior, but it lost a great deal of its iron, and due to the collision that actually created it, as we're going to talk about today. There are the escape velocities. Notice, of course, the escape velocity from the Moon is the lowest because has the least mass. All right. So the Moon, when you look out at the Moon, there's actually 2 areas. These dark regions are called Maria. That's Latin for sea. The brighter regions are called the Highlands. And of course, the Sea of Tranquility is where Apollo 11 landed. That's the first place that humans visited on the Moon. Now, why are the Maria dark? That's actually a really good question, and it actually has to do with the very early stages of the solar system, when the Moon still had a molten interior. When asteroids or comets or anything large enough to crash through the crust, break through the crust of the Moon, the outer shell, if you will, of the Moon, then what happened is, you would have craters, of course, just like there are craters now, but because this was the early stage of the Moon, and it still had a molten interior, then what happened was lava would flow out and fill up the basins, and actually the astronauts brought back some of this material, and it turns out that it's exactly the same type of material that we find close to lava, close to volcanoes, where there's been a lava flow and that lava flow was made of what's called basalt. And when that basalt cools, it becomes very dark, just like the Maria on the surface of the moon. All right, so there are craters everywhere. I mean, the Maria look like there's no craters, but because they look very smooth. But there are very many craters all over the Maria. It turns out there's not as many Maria. In fact, there's hardly any at all on the other side of the moon. Now, I'll try to refrain from talking about the dark side of the moon. It's not dark at all. It's just not visible from our vantage point on the Earth. You have to send a satellite to the other side of the moon to actually be able to view it. And of course, different amounts of sunlight hit that side of the moon. That side of the moon, the opposite side of the moon, is actually the crust. It turns out to be a little bit thicker on that side, and we think that is really why there are virtually no Maria on the other side. Because that thicker crust, when objects would have hit that other side, which certainly would have happened just as often as this side of the moon, the side that faces the Earth, that extra thickness, prevented the crust from being broken completely through, and so the molten lava would not have made it, into the basins. All right, so here are some nice pictures of craters. Most of them have names. A lot of them are named after famous scientists. But the thing that's important about this, and this, you're going to hear me say this idea over and over. The moon is basically, just like Mercury, the moon is a dead world. The surface of the moon and the surface of Mercury have not changed really almost since the beginning of the solar system, 4.5 billion years ago. And so the thing that changes the surfaces of Mercury and the moon is simply impacts, objects, meteorites, so either comets or asteroids, little bits of debris that are left over from the formation of the solar system, crash into the moon and crash. These things actually crash into all the planets and all the moons all over the solar system. We see evidence of this, and of course these things have hit the Earth as well. But of course the Earth has geology, and it also has weathering, right? Because of our thick atmosphere, or relatively thick atmosphere. And so evidence of these impacts on the surface of the Earth gets erased over time. All right. So there's this far side of the moon, and you can see there's hardly any Maria at all. All right. So and as I mentioned, that's because the crust is thicker in that direction, or on that side of the moon. All right. So Mercury. Oh, there's talking about the Messenger spacecraft. So the Messenger spacecraft is, it wasn't launched just recently. It's, I think it was in the early 2000s that it was launched. Anyhow, that's given us the best detail of the surface of the planet Mercury. Notice, it basically looks just like the moon, as far as craters go. You don't really see Maria, however. There are actually some really interesting features on the surface of Mercury. We'll get into that in just a little bit. So the craters are very similar. Let's see. Yeah, so anyhow, let's move on here. Let's see. Actually, I'm almost out of time here. So this is something I'll talk more about this in the next video. But this is why we only see one side of the moon. It's because it's tidally locked. It's in what's called synchronous orbit around our Earth. it does spin about its axis, but it spins at the same rate that it revolves around the Earth.